Once we deal with sound, so in a system, and أنا دلوقتي بتكلم, there's a sound, but the sound is converted to something here that is managed in the mixer, and then it converted to sound again. It starts with sound, and then something, and then becomes sound again. We covered the beginning and the end pieces, but what happens in the mixer is all electronic, right? مين فاكر ده بيسموه ايه so what are the types of electric currents? Alternating and direct, right? Does anyone does not know that? What is the difference, JP, what is the difference between the alternating current and the direct current? Good, so when you have, any wire has usually two wires, right? When in a direct current, one is always positive, one is always negative, so the electrons pass one way. But in the alternating current, actually, it goes back and forth, right? All of the outlets, all of the power outlets are AC. So any electric distribution in general, all of the sockets we have in the walls are alternating current. But once it goes into a transformer, whether it's outside like this computer, or inside the mixer, or inside any equipment, it gets converted to a circuit called rectifier, et cetera, to a DC, a direct current. So in audio, we deal with DC current, direct current, which has a positive and a negative, right? One is always positive, one is always negative. And characteristic of electric currents is the Ohm's law. مين فاكر Ohm's law? The relationship between كريم بيضحك نسأل كده. So any flow of electrons in a circuit is characterized by three, can be, is a relationship between three things, right? So electrons are, think about it like water hose, right? The one on the left. If I open the tap, the water flows this way, right? So if I open this, it's a pump, it pushes the water here. The more I open it up, the more it flows, right? So that's the potential difference, that's the voltage. V, right? And then, depending on what's in the hose, if I squeeze that hose in here, while it's open the same way, the water will slow down or get faster. If I squeeze this. Slow down. So this is the resistance. This is the circuit resistance. So for the same voltage, if I squeeze this down, the voltage is the same, but the flow will be less, right? It's called the current. So voltage, resistance, current. Voltage is what the pump is pushing. Resistance is the sand in that pipe, and current is the result of these two. And this is the relationship in here. So voltage equals current times resistance, and the same thing, resistance is voltage divided by current, or current is voltage divided by resistance, right? This is important. I know this is simple, and this is what I was referring to as grade A, but it's extremely important in everything, because if you don't follow many things in this, you actually can blow speakers, you can blow amplifiers that cost thousands of dollars, simply because you don't understand this concept. I'm not kidding. And so, فاهمين? عشان كده, maybe you don't perceive this in a setup like this, but when you are actually taking all of your equipment and go to a place for a temporary setup, you have to know exactly what is what. لأنه speakers can be from 2 ohm to 816 ohm, and the amplifiers, if they are pushing a lot of current on a small speaker, it will blow the speaker. Or if the resistance in the speaker is much lower, it will drag more current, and I mean, they are all interrelated, right? It's a circuit. So it happens in every bit in electric circuits, including the mixers and the amplifiers and the speakers and everything. So this rule applies to everything. Any questions about that? And again, this is just another very much another picture, and this is what I was referring to, is the voltage is how much water in this tank. If it's a bigger tank and it's pushing it hard, you increase the voltage. But the width of the pipe is the current, dictates the current. If you put a wider pipe, it will draw more. And the resistance is how much resistance within that system, whether it's within the actual, like there are many things that bring resistance to a circuit. But in general, this is very important that if you increase the voltage with the same resistance, the current will. So if the resistance is the same, but I push more water, what's going to happen to the current? I push more water, I increase the pump. So there'll be more current, right? Right? If I reduce the resistance on the same voltage, the current will be more as well because it faces less resistance, right? The second very important phenomenon that we need to be aware of is electromagnetic interaction. Again, I'll tell you why this is important, but I wonder if you remember this, which is you can generate electricity by moving a magnetic field in a coil. Do we all know that, right? And we see that all the time. We see that in the الدينامو بتاع العربية اسمه ايه بالانجليزي؟ alternator? No, not alternator. Alternator. So when you can generate electricity, you remember those flashlights that you actually can turn and then they light up? So they have a small dynamo, it has alternator that when it converges that, it has a magnet that when you do that, it moves the magnets within a coil, so electricity is generated in the coil and it lights a lamp, right? The same in your car, when you move, what charges the battery is an alternator. It takes the movement of the car, so you use the gas to generate kinetic energy, and this kinetic energy eventually charges the battery through an alternator. The opposite of that is a motor, right? You give it electricity, and it generates motion or kinetic energy, right? But they are both the same thing. If you have a magnet here, and you put electricity in that coil, the magnet will move, right? And the opposite is if you move the magnet in a coil, it will generate electricity in that coil, right? Why this is important? Because it is everything in and out. So this microphone, the way it functions is that it converts my sound waves to sort of electricity, right? And how it does that, if I take this off, I showed some of you that, you would look inside, there will be something like this called the mic capsule, which is that golden thing, right? And in that golden thing, inside of it, there is a diaphragm, which is that golden plate that you saw. And this golden plate is attached to a coil, and the coil is fitted on a magnet. So once I speak, the coil is very sensitive. Actually, you know, the thickness is in microns, so it's very thin, right? That's why it is the most expensive piece in this microphone. It's not the actual microphone, it's actually this, right? And then once I talk, there's very little movement here because it's attached to a coil and there's a magnet, it generates some electrical signal. I take this electrical signal in the wire and deal with it, right? That's why microphones are very sensitive to dropping. Why? Because the alignment, because number one, this diaphragm is very, very, very thin, as I said, and with any shock, two things can happen. You can change the alignment, so if it's not perfectly at the center of the coil, actually it doesn't move freely. I think we have one of the wireless microphone upstairs that if you use it, actually it sounds a little bit different, and I think somebody dropped it, and I think one in here as well. So if you use a microphone, my voice doesn't and then you change the microphone and it sounds nice, that means that there's something wrong with this capsule if they both have the same setting on the mixer, obviously, right? So if I move this mic and put another mic on the same channel, it sounds different. That's likely, and it should be the same brand, likely one of them is something wrong with it, right? And at the end, the opposite happens, which happens to this speaker. So I take this signal, I deal with it in the mixer, I color it the way I want, I mix it with other instruments, and then I send it to an amplifier that bump it up and send it to this guy, which is the speaker. So it takes the amplified electric energy to a coil that is fitted on a magnet, and once the electricity goes in, it moves that diaphragm that I showed you in the first picture. It pushes the air, and you listen to it, right? Make sense? Any questions?